Hi, I'm Joshua Rubin, principal AI scientist at Fiddler AI, and I've been with Fiddler for almost 5 years now. Fun fact about me, I guess that most people don't know, is I used to be a physicist, and I got to work internationally. So my thesis experiment was in Germany, and it turns out one of the big pulls for me into that particular field was that I got to travel a lot. And so I spent 6 years or something like that visiting all sorts of amazing collaborators all over the world doing really interesting work before I decided to get into tech and build things. Fiddler is an observability platform for AI. For both generative and predictive AI, we handle structured and unstructured data, so you can kind of think about it like a cockpit of telemetry that allows you to monitor how one of these, potentially complicated AI systems is working in production settings. You can monitor things like unstructured data drift, so you might care about are users asking your chatbot new questions that it might not have been trained on or might not be prepared for? Is there content that's missing from your document store? So we can track those kinds of semantic shifts. We have things that we call trust models, which I'll be talking about later today, but it's, essentially models that are used to evaluate the outputs of other models so that you can track performance of an AI application in production. We love human feedback when it's available, but it's not too frequent that people click thumbs up or thumbs down and provide rich feedback for things. So having a system of instrumentation around your AI models that allows you to track model performance and root cause problems as they're occurring or identify common failure modes is super important. And it's particularly challenging to do that in the world of kind of unstructured data where all this new generative AI stuff lives. So my journey from early days in tech, I grew up in Silicon Valley, so that's my secret wild card is my father was actually in shrink-wrapped software when I was young. So I think I was always destined to go down this path, but I'm a physicist by training. So I did a PhD and I spent a bunch of years as a postdoc studying the structure of matter. These physics problems are things that some really smart humans picked all the low-hanging fruit on 100 years ago, right? And so for the modest intellects of the world, such as myself, there's tons of amazing things you can build with technology. And so, I was looking at an academic career and decided that it might just be more fun and more interesting and more satisfying to go and build things using tech. AI was just rolling on. This is maybe, 7, 8 years ago. AI was just starting to roll onto the scene as a big deal. And so all of a sudden, we had things like, like AlexNet and people were starting to talk about sequence processing AI models. There was that amazing work by Andrei Karpathy where he was talking about, there's this thing called the unreasonable effectiveness of neural nets, where he talks about all the amazing things you can do with sequence processing models. And so I just got really excited about the stuff you could build there. And so I sort of turned my physics skills, which were simulations, data, statistics, data processing, parallel computing, into data science, spent a little bit of time as a freelance data scientist, and then found my way to Fiddler, where I've been working on this stuff. And I'm super happy with the choice. Building stuff is super fun, and it's amazing to see that there are things you can do today that are important to people that, you couldn't do just a couple of years ago. Being on that edge of technology is super, super fun. Just to focus on generative AI and LLMs for a minute, I think these applications are getting more complex. One is that the data input and output is unstructured. So in the old days, if you were trying to you were a bank and you were scoring a loan applicant, you knew they were from some region and they were in some demographic bracket and they had this much income and this much debt to income ratio. You had this kind of tabular data set, and it's easy to draw boxes around segments of that and say, how is the performance for, people older than 50 years old on the East Coast? How does that compare with the model as a whole? Is the model underperforming there? In the generative AI world with this unstructured data, it's harder to draw boundaries around model application behavior that's underperforming. And the other thing is that, we used to live in this AI world where models were trained for the same task where they're applied. And now we train these LLMs on this guess the next token task. And then we go and we ask them for life advice, right? Like it's this totally different task. So the ground truth label, whether the model's performing well or not, is like divorced from its training label. And you have to think a little bit more carefully about how you measure the performance of the model, right? And so taking those two things together, as generative applications get bigger, it's not just an LLM, it's an LLM and a database, or an LLM and a database and some integration with a workflow, or an LLM and database integration with a workflow and some sort of open-ended action taking when you start getting into this like agentic AI stuff. I think what we're going to see is an increased need for telemetry on how these applications are performing, because they start looking like it's not just a model, right? It's a constellation of different technical pieces, maybe different LLMs that are working together to solve a problem in complex ways. And, you need to be able to identify failure modes. You need to be able to identify when the world has changed in some way where users need something different of their application than they did last week, and not spend a huge amount of time with an underperforming application because your model didn't know about some event in the world that people care about. One thing I've learned in my 5 years at Fiddler is there are a lot of really interesting niche use cases out there where somebody who's kind of nerdy like me, who likes to work on hard problems, can go down that rabbit hole and spend a whole lot of energy focusing on one or two people's kind of niche problem. It pays to look across the spectrum of use cases, and try to identify first, like, a broad-based need. And second, to think about how to build tools in a way that they can be abstracted to different use cases, so that, like, without specifically trying to solve for the niche case, a tool like Fiddler can be configured to accommodate weird niche use cases because its combination of tooling is kind of composable and well abstracted. Nature has shown us, this is kind of the existence proof, that there are algorithms out there that solve some of these problems much, much more efficiently than the current trend of how we build intelligent algorithms. We're likely to find other ways to solve these problems that are more compute efficient, more training efficient, more power efficient. That could happen at any time, right? Somebody in a research lab is going to be like, oh, here's a different way we can address this problem, or here's a different kind of architecture. I think agentic AI, I think we're already starting to see, startups with really interesting sort of agentic use cases that are more like assistants, travel assistants that can pull data from lots of different live sources, can, book travel for you, can learn your preferences and remember it across settings. I think memory is going to be big, right? We're just beginning to scratch the surface of the user interface for generative AI, right? Like this chat interface, you can go on, OpenAI, you can get on ChatGPT and have a verbal conversation with it, but it feels artificial, right? You wait for 2 minutes while it gives you this long, 5-paragraph essay on, why your AI training job might not be working well. But it's not a natural flow, right? We're missing visual cues that we get from human beings when we talk to them. We're missing the natural flow of conversation. I think we're likely to see developments that make our interactions with these applications much more natural, right? Things that make it easier for humans to consume in the way that we communicate with other humans. I think agentic AI is kind of the easy answer, because I think everybody's sort of thinking about that. These more sophisticated applications that have access to more tools, more data sources, more general workflow integrations that become our assistants, remember our needs, remember our preferences. But I think there's this element of like ergonomic human interaction that we haven't even really begun to scratch the surface on, and it's super interesting. I think building stuff is really good. I think getting your hands dirty with tools is really good. But I think having technical versatility is really important. People talk about grit, right, when they're hiring. Can you think about a problem in the abstract and kind of assemble whatever configuration of tools you need to make that work? I think as a core skill, kind of technical grit and versatility is key. And I think you only get that by cobbling a lot of weird projects together and probably not just following cookbooks. I mean, you can get like, how do you spin up this kind of database from a cookbook? People spend whole kind of beginnings of careers focusing on, optimizing performance metrics of classifiers. There's this whole kind of school of, people who do Kaggle competitions, and by all means have a ball if that's what you love. and you want to eke out a few more % of performance on a particularly tricky data set. I mean, there's some value to that too. But that's not where the whole game is. Part of it is technical versatility. It's being able to select the right tools and stick them together. Get humble. Like, internships help. Unpaid internships are fine. You have a long career to, build your earning potential, right? Like, when we're looking at resumes, I think a thing that we care a lot about is, has this junior person had a couple of good internships, where they've worked on interesting problems and thought about those problems deeply.